So at Notre Dame, football is such an ingrained part of our culture that we even have an engineering club for it. Robotic football started in 2007 as a senior design project at Notre Dame. In 2011, it was expanded to include a club, and in 2012, we became intercollegiate. We currently have 6 different schools in our league, and we've been growing rapidly every year. So last year, we had approximately 20 members, and this year we have more than 70.
All right, so let's do a quick run through of all our different robots that we have on the team. This is our standard base and lineman.
This is our center.
This is the robot that you see out here on the stage, our quarterback.
And this is our kicker.
Alrighty, so let's go ahead and dive a little bit deeper into these robots and really what makes them up. So on the screen, you can see our standard base / lineman. When we designed this, we wanted to make sure that we had something that was easy to change out the parts, something that could be operated on the sidelines during a game, and something that wasn't too expensive, relatively. So on the screen, you can see in the center, we have our battery and a tackle sensor. So that way, when a robot gets tackled on the field, it changes its LEDs on the side, and that's the end of the play. On the bottom left, that's the brain of our robot. It's an Arduino with a XB shield and XB. This is what communicates with our controller and controls the motor controller, which you can see on the left. And then at the top are our motors. Then the idea behind the standard base is we have interchangeable tops, which you'll see here in the next couple slides. So that way, a lineman can become a center, can become a wide receiver, and it makes it really easy to program them.
So this is our center, and as you can see, it's also based on our standard base like Aaron was just describing. On top of it, there's a tower, and then on top of that, there is a servo-driven mechanism which pushes the slider, but has a claw that holds the ball out into this quarterback so that the quarterback can take the ball.
Alrighty, so now for the really exciting and really complicated robot that consumes a lot of our time. So we took the standard base and just threw a lot more electronics in there, as you can see in the picture there. We added another Arduino because we wanted to add a little bit of semi-autonomous functionality. We have a Pixie Cam, which sits on our top, right up top there, and that can do a little bit of color and blob detection. So our wide receivers are these giant curtained robots with different colors, and with the camera, we can get the angle to the robot, and we can also detect distance. So that way we can ramp up our motors and throw to the different wide receivers by clicking different colored buttons on our controller. And that really takes a lot of the control away from the user so that we can run really complicated plays that we might not have been able to run through before. And we have plans this semester to really ramp that up and make it a lot more complicated and even push more of the functionality over to the computer.
Yeah, so this is our kicker. Once again, it's based on the standard base, and off to the side, there's a leg. The leg has different springs attached to it, and you can interchange those depending on how far you want to kick. The leg is pulled back and held in place by a pin that's attached to a linear actuator. And then when the linear actuator is released, the leg's released and it kicks the ball.
All right, so now for the fun part. We're actually going to do a live demo on stage. So I'll ask Zoe to line up. I'll throw back up a little bit and get ready to throw a pass.
Yeah.
Get it lined up there a little bit to the left. All right, so this ball is actually fed in from the center, so I'll go ahead and turn this on. This sucks the ball in, but it's already in the holder for now. I'll go ahead and reverse that, get it lined up a little bit more, a little bit to the left. Ooh, a little bit too much there. Perfect. All right, let's go ahead and ramp it up. And fire. Perfect. All righty. Grab that back over. All right, so what's next? So this is actually going to be a really, really fun semester. We're really looking forward to seeing what we have with the new members that we have. We actually have been growing exponentially the past couple years, so we went from a team of about 5 to a team of about 10 to 15 to now over 70 active dues-paying members. So as you can see up on the screen, this is our newest addition to the team last year because we also are part senior design. One of our seniors designed for us a new autonomous running back, as you can see here. We slimmed it down a little bit. We actually added a LiDAR in the middle, which was super exciting. We used Omni wheels, so that way it can move in every direction without turning. And it even has a gyroscope, so that way you can kick it and turn it, and it will always reorient itself back to where it needs to be. And the interesting part of this is that it has created a lot of software challenges. So I've actually started heading up a new division of our robotic football club devoted to software. because this really used to be a purely mechanical club, and now we're really going more towards software and trying to solve those challenges. Like even last night at dinner, we were sitting around the table talking about nothing but robots, even though we were done for the day and really wanted to relax, but that was what really interested us. So if you want to visit our website, you can just Google Notre Dame Robotic Football, and we'd love to share with you what's next. Thank you.